Kirko Math. All right, ladies and gentlemen, we are going to review some important information here. This video is about simplifying radicals. So this is a review lesson. We're in the middle of topic 9, but we're going to review what a radical is and how to kind of simplify and how to find square roots. So let's begin. Okay, first vocabulary word we have here is a perfect square. So a perfect square is a number which is the solution when an integer is multiplied by itself. So here you can see in our chart, all of these are perfect squares down here in a diagonal on our multiplication chart because it's 1 times 1, it's 2 times 2, it's 3 times 3. So when any integer, including negative numbers, is multiplied by itself, we get a perfect square. Okay, perfect squares are called perfect squares because if I put a square that is 2 by 2, I get the answer, which is 4. It makes the shape of a perfect square. Pretty straightforward there. The next word we're going to review is a radical. So a radical is used to define the root of a function. So we're looking at square roots, cube roots to the 4th. This is a diagram of what a radical is. So you have your radical symbol, okay, which kind of looks like a long division sign, but also a check mark. Inside your radical symbol, you have the radicand. The entire thing is called a radical. And then whatever the number is in front here, and if there's no number, we know that's a 2 for a square root. But if there's a number here, we call that an index, okay? But this right here, this whole thing is a radical. We've used them before. And then the last vocabulary word is prime factorization. So prime factorization is expressing a number as a product of prime factors. So typically we use something called a prime factor tree. Some of you may have learned a prime factor ladder. It's pretty much the same thing as a tree. They just use this kind of L shape. And then they might say, okay, that's 25 and that's, well, no. They actually do prime numbers on the outside here. So they might say, okay, that's 5. And then they divide and say, okay, so then this becomes 7, 0. And then they draw a new little ladder. And once you keep going through this, keeping prime numbers on the outside, it kind of looks like a ladder. But it ends up doing the same thing. And so what you get, though, is this list of prime factor numbers, okay? Any duplicate numbers get raised to a power. So I had 2 5s in the end, and all of these orange numbers are prime. So we did 2 times 5, or 5 squared times 17, and that is the prime factorization of 850. So we're going to review these things today. You've seen them before. But you just might not have used them in a while, so we're going to review them. All right, so on this first page, we're going to start by just reviewing what a perfect square is. So all of these numbers here where it says find the solution for x are perfect squares. We solve our perfect squares. It's just like an equation by doing the square root of both sides. You're then going to get x equals, and you will always have 2 answers, okay? A number times itself that makes 49 is 7, but also negative 7, and that's because 7 times 7 is 49, and negative 7 times 7, negative 7 is 49, because a negative times a negative makes a positive. So for all of these perfect squares, they have 2 solutions, a positive and a negative. So then if I solve this one, the square root of 225, is going to be a positive and a negative, and sometimes we use that symbol right there to show positive and negative. And also sometimes we just use our calculators, because some of these I've memorized and you may have memorized, and then some of the bigger numbers you might not have memorized yet. If you do know it, good for you. But just to show you how you do it on a calculator, you're going to do 225 and you're going to hit that square root button and we get 15. So 15 times 15 and negative 15 times negative 15. So that's what that symbol means right there. So go ahead and do the square root of 81 and 361 on your own, and we will double check them in class. Down here, the next thing that we are going to review is how to do prime factorization, okay? So to do prime factorization, like I said earlier, we're going to make a tree. So I'm going to grab a random number, like let's do 24. Oh, hold on. There we go. Let's do 24. So over here, we're going to practice. So ideally, if you can find a prime number to pull out, you're going to basically pull out two factors of 24. But like I said, if you can pull out a prime number, that's great. But the nice thing about a tree is you don't have to. So I know that 6 times 4 makes 24. Neither 6 or 4 is prime, so I'm going to continue branching down. Once I get to a prime number, I'm going to circle it, okay? 6 is 2 times 3. Now both 2 and 3 are prime. 4 is 2 times 2. Okay, and once you have all your numbers prime, you now have your prime factorization. So you organize your numbers in order from small to big, and then you group all the numbers that are the same with an exponent. So the prime factorization of 24 is 2 cubed times 3. Now you might be saying, but Ms. Kirkwood, what if I didn't do 6 and 4 as my factors? That's okay. You'll still get the same answer. So if you did 24, but you did 2 times 12, you're still going to circle 2 because it's prime, and then I'm just going to break apart the 12. Well, 12 is 2 times 6. Okay, that's prime. Break apart the 6. 2 times 3. Oh, look, I still end up with 1, 2, 3 2s and 1 3. So you get the same prime factorization there. So we're going to go ahead and do one of these together, and then you're going to do one on your own. All right, so we're going to break this apart. And I'm going to find two factors. Now I'm going to think 27, 7, 8, 9. I know that 27 is divisible by 9 and it goes in 3 times. And because of my zeros, I'm going to add them to the end. So I have 9 and 300. Now 9 is not prime, but the factors that make 9 are 300 is not prime, but I know that that's 3 times 100. And then I'm going to break apart 100. So 100 is 2 and 50. 50 is 2 and 25. And 25 is 5 times 5. All right. I am now going to put all of my numbers together so you can even count them. I've got 2 2s. I've got 3 3s. And I've got 2 5s. So just like in standard form of our equations, you do want to put them in order from least to greatest. And that's how you do prime factorization with a prime factor tree. So go ahead and try to prime factor 1600. All right, so now that we're going to apply our property of perfect squares to some of these problems that have something a little bit different we need to remember. So we have a property here that tells me that if I have a fraction inside of my radical symbol, I can apply that radical symbol to the numerator and the denominator separately. So all I have to do is find the square root of 81 and the square root of 16, and I am going to get 9 fourths. And as long as my fraction is simplified and I can't reduce it anymore, that can be my solution. I'm done. Okay, over here I have this extra number in front. So kind of think of it like a mixed number, like a fraction, where that 2 is really being multiplied well, not like a mixed number. Think of it more like 2a, like with a variable in front of it where it's being multiplied. So this is really 2 times the square root of 100 over 64, or the square root of 100 over the square root of 64. And so what I'm going to do is actually multiply this out. So the square root of 100 is 10. The square root of 64 is 8. Okay, and then I'm going to multiply, but my fraction isn't simplified, so I'm going to reduce my fraction and divide them both by 2 and get 2 times 5/4. Okay, now to multiply my fractions, I'm actually going to reduce it first just to simplify and make it a little bit easier. So my answer is 5/2. Now I can keep it a fraction like this, or I can turn it into a decimal and make it 2.5. Okay, so this one or this one are correct. Remember, most things that we're doing in algebra we keep as fractions, but you can simplify further into a decimal. So go ahead and see if you can try the -3 times the square root of 36 over 49. And then we're going to simplify the radicals on the bottom. So what's special about these radicals here is that they are not perfect squares. And if you remember from Math 7-8 or in 8th grade, we learned how to approximate these square roots, meaning basically to estimate them. But there's another way to do that. And the way to do that is to kind of simplify them and make them look like a problem up here in a way where you can pull out a perfect square and get a whole number and then have a square root underneath of the piece that is not perfect. So what I'm going to do is factor out the 32 into 2 numbers. And this is where the knowledge of our prime factor tree comes in handy. Ideally, you want at least one term to be a perfect square so that you can pull that out of the radical and turn it into a whole number. That would be ideal. So I'm going to think of 2 numbers that multiply together to make 32, and one of them is a perfect square. So we're going to go ahead and do 16 times 2. 2 is prime. 16 is a perfect square. Okay? It doesn't really matter that 2 is prime. I'm just kind of pointing that out for you. But 16 is a perfect square. So what we're going to do, well, it kind of matters. We'll explain. What we're going to do now is we're going to say, okay, so 16 times 2 is really the same as the 32. So the square root of 32 is the same as the square root of 16 times 2. When I put this radicand inside my radical symbol, my properties tell me that I can break them apart and say that if I have a product inside my radical symbol, I can break them apart into 2 products with radical symbols. So the square root of 16 times 2 turns into the square root of 16 times the square root of 2. The square root of 16 is 4, and the square root of 2, because 2 is prime, I can't solve. So I'm going to just leave it next to 4 as a multiplication problem, and that is my solution. So the square root of 32 is the same as 4 times the square root of 2. Okay, so again, we factored out a perfect square. And then we basically just simplified the products. Those are kind of my steps for simplifying a radical. Okay, let's try 150, and then I'll let you do 252 on your own. So again, I need to pull out 2 numbers that multiply to make 150, and ideally one of them needs to be a perfect square. So we're going to do 25 and 6, and I just use my calculator to help me out. So that turns into the square root of 25 times 6, which is the square root of 25 times the square root of 6. The square root of 25 is 5, and 6 is not a perfect square, so that is my answer. So go ahead and do this one on your own, and we'll see you in class. All right, finally, go ahead and try these independent practice problems without examples on the screen and see what you can do.